Hello and welcome to our next video on our Chapter 6 Normal Distributions. Picking back up, we're going to go right into number 12 because practice problem 6 is going to be a lot of videos here. We have a lot to get to. A lot of it's once you get going, we're doing a lot of the same things over and over again, so hopefully as you go, you'll start picking up on it a little bit better. So number 12, as we're working through our packet here, we're just going through, the kind of basic steps of finding our z value here. So we have an IQ score. IQ scores are on a normal distribution with a mean of 100 and a standard deviation of 16. And Albert Einstein reportedly had an IQ of 160. So what I've done here is, instead of drawing it out, if we were at our mu, we had our mu value of 100, and then we went up 1, 2, 3, 4 standard deviations, this is where they would land. But so I wanted to set it up. Part A asks, what's the difference between Einstein's IQ and the mean? So when we're trying to find the difference, we're subtracting. So 160 minus the mean, what is Einstein's IQ from the mean? And we get a value of 60. How many standard deviations is that? Well, if we kind of look, right, we kind of know that the difference is 60. And the difference from 100 to 164, 160 would fall really close to almost 4, but not quite 4. It would be between 3 and 4. But since it doesn't land on an exact value there, we don't, we could say that there's 3 to 4 standard deviations, or between 3 and 4 standard deviations is where it is. It's not an exact value. However, when we convert it to a z-score, so remember, a z-score is equal to x minus mu over the standard deviation. Our x being 160, our mu being 100, and our standard deviation being 16. When we do that, we get a value of 3.75, which is, remember, a z is just kind of like a fancy way of saying how many standard deviations away from the mean it is. And we knew that his mean was between 3 and 4 standard deviations, but it didn't land on an exact value. It's 3 3/4 or 3.75 standard deviations away from the mean. So that's where his IQ score is. Now, part D talks about when we have unusual IQ scores, that a usual IQ score is between -2 and 2 is Einstein's IQ score, usual or unusual. So remember, when we do between -2 and 2 standard deviations from the mean, it's going to be 95% of, the population, or 95% of the people, the participants, are going to fall within that. And so does Einstein's IQ fall within -2 or 2? No, his is 3.75, so we consider this to be unusual. And in statistics, that's what we're looking for. We're looking to see if you're kind of outside this 95% area here. Moving on to number 13, we have z percentiles falling into z percentiles. Find the following z percentiles. So remember, if you have a z and then you have this underscore value, right, this value here, we're looking for this percent and then converting it to the z value it is. So you go into the middle of the table and you find your percentile at 10% here, and then you find 10%, you find, or it's not going to be an exact value, so you find the value that's going to be closest to 10%. You might be a little above it, might be a little below it, so you're going to kind of have to look at it and determine which value is the closest to it. Once you do that, then you find out where that lands and find your z value, and you get -1.28. I'm going to just write these out here. This one is a little bit harder to really talk about. It's much easier to look at the table and keep going and try it yourself. There's also many videos that show you how to do this, other than the ones in the course here. And if you always need help, always stop by. I'll be more than happy to go through the tables with you. But understanding, when you see a z and then an underscore value here, we're having our percentile. So we're trying to take this percentile we're finding and moving it and finding the z value of it, which is what we're doing. We're finding the 10th percentile, and the z value that's associated with it is -1.28. Moving on to number 14, what is the probability associated between these outcomes? Where we have x is normally distributed right? We have an n value normally distributed 8, 1.5. So we know our mu is 8 and our standard deviation is 1.5. So if you wanted to, we can kind of move this here. We can kind of graph this out if you want to. Draw your graph. You have your mu, and we know mu is 8. And if we wanted to go, I put our tick marks here for plus 1, plus 2, plus 3 standard deviations. This is 9.5, 11, and apparently I can't add in my head right now. 12.5, and we keep doing that so that you can do this all the way out as well. Subtract it out and you get 6.5 and so on and so forth. So if you prefer to draw it, definitely draw it out if it helps you visualize it more, but it's not necessary to do if you don't want to. So we want to find what is the probability between 6.5 and 9.5, and so now these are two x values. So this is very similar to what we were doing way up here in our problems, 7, 8, 9, 10, right here. So we're finding, when we're finding percentiles between values with the normal distribution, that's what we're doing here. We're just finding out the probability percentiles. That's where we're getting to with all of this. So we have two x values, and if we know our z is equal to x minus mu over the standard deviation, we want to find between values, and we're going to be subtracting them out just like we did. Now if you look at the graph here, what's one thing you kind of might notice? That 6.5 and 9.5 fall exactly plus or minus 1 standard deviation away from the mean. So we know this value should be about 68%. And when we work that out on paper, you get 6.5 minus 8 all over 1.5 equals -1, and 9.5 minus 8 all over 1.5 equals a +1. When we go to the table in the back, remember this is our z, might always be helpful to write what these values equal z, and we have to go to our tables now. -1 is going to be 0.1587. A value of 1 is 0.8413. If you take 0.8413, subtract it from 0.1587, you're going to get a value of 0.6826, or 68%, just about there. Moving along between 5 and 11, if we were to keep writing this out, that'd be value 5. So we know we're going plus or minus 2 standard deviation. We know it should be about 95%. Should be approximately 95%. When we do it out, 5 minus 8 over 1.8 equals -2. When we go to our table in the back, that's going to be 0.0228. Our next value, 11 minus 8 divided by 1.5 equals 2. In the table in the back, 0.9772. Subtract these out from each other because we're finding the difference between 0.0228, and we get a value of 0.9544, approximately 95%. Next one we're doing between 8 and 11, so 8 and 11 there. So between the mean, which we know 8 is going to be 50, right? If we do it, 8 minus 8 is going to be 0, divided by 1.5, 0 over 1.5 is going to be 0, so we know it's going to be a value of 0.5. 11 minus 8, well, we just kind of did that right in the problem above, right? From right there, so let's just copy that over. So we're going to take 0.9772 minus 0.5, and we're going to get a value of 0.4772. All right, moving along here, we have our study. So we're setting up with the mean and another standard deviation. This will be our last one. All right, so we have our mean and our standard deviation here. What is the percentile rank? And then number 15. So we have Alzheimer's disease test. Sorry, I was looking at 16, wondering what was going on. And we have this person at the Alzheimer's test scored 45, and the mean on the test is a 52 with a standard deviation of 15. So let's write all our values off to the side here. Our person of interest here, who is x, got a 45. Our x value is 45. Our mean here for this test is 52, and our standard deviation is 5. And then we know what percentile rank does he fall in. So where is this, on the normal distribution, where does he fall? So we take our z-score, and you take 45 minus 52 divided by a standard deviation of 5. When we work that out, we're going to get a value of negative 1.4. We go, remember this is our z, take 1.4, because that's not a percentile or rank. We go negative 1.44, and we'll find a value of 0.0808, which is where this person who has Alzheimer's ranked on a test, so it's very low. Alright, I'm going to try to do this next one a little quicker, just for the value of time. Alright, so now we have, suppose n is normally distributed with a mean of 275 and a standard deviation of 16. We want to find the probability of x being greater than 294. So remember, when we're doing greater than, we're going to find the value at x and then subtract it from 1. So we're going to take 294 minus 275 divided by 16. It's going to give us the value of 1.18. When we go to our table in the back, we'll find that that is cumulative probability of 0.8810. Now remember, that's everything from that value to the left, but we want to know the greater than, so we're going to take 1 minus 0.8810, and that's going to give us 0.119, and that is your answer. We're trying to find the probability between two values, just like we were doing above. We have two now values of x that we're trying to find between, so we're going to 255 minus 275 divided by the standard deviation of 16 equals negative 1.25. When we go to our table in the back, we'll find that to be 0.1056, and then we go 297 minus 275 divided by standard deviation of 16 equals 1.37. Go to our table in the back, get 0.9147. Subtract these values out to find the value between them, and you'll end up with 0.8091. Alright, next one here, we're trying to find the 17th percentile of x. So this is where, if you were to take our equation of x minus mu divided by standard deviation and rewrite it out to just solve for the value of x, our equation is going to look, x is going to equal our z times standard deviation plus our mu. Well, our z needs to be a z value, so we know we need to find the z 0.17 or the 17th percentile of z. So now we're going to take z of the 17th percentile, so we have to go find 17 in the book, find the z value that's equated to it, and you'll notice that's negative 0.95. Our standard deviation is still 16 from above, and our mean is 275. Oh, I even said it, I don't know why I wrote it that way. 275. And when we solve all that out, we get a value of 259.8. Now this is the value at the 17th percentile. This is the value of x at the 17th percentile with this distribution here. Alright, that's going to conclude everything for this video. I'll catch you all in the next one.